We'll move on to magnetostriction. So before we look at the method, how it generates, let's understand what the process of magnetostriction is. So you have a rod made of some magnetic material. It has tiny particles or domains inside it, which are magnetic particles. These are the particles which a magnet attracts, which get attracted when you put in a magnetic field. So they are called domains. Now you apply some force, some magnetic field on this rod. All these domains, which are initially randomly placed, they all get aligned in the direction of the magnetic field. So when that happens, there is a small elongation. So let's say you had a magnetic particle which was inclined like this. Now you apply some sort of force, it becomes horizontal. So there is a small elongation. So when that elongation happens, the rod itself is expanding. It is a very small elongation, very minute. It's of the order around 1/25,000 of the length of the rod. So it won't be visible to the naked eye, but there is an expansion or elongation of the rod. And what does that cause? It pushes the air around it. So when this rod or cylindrical thing you have, when it expands, it pushes the air around it. So, and when you push air column, a vibration is created, and that vibration is what gives rise to a sound wave. So what is the basic principle here? We have a magnetic material, it has small magnetic domains inside it. I am applying a magnetic field, those domains all get aligned in the direction of the field. Because of this alignment, there is a small elongation of the rod. That elongation vibrates the air surrounding the rod. That vibration leads to ultrasonic sound generation. Now this is just the theory of it. We will be looking at a very structured way of using this. We'll come to that in a minute. But before that, there's a couple of things we need to keep in mind. Firstly, the length increase is very small. The change occurs very fast, around 1 microsecond, and the length increase only depends upon the magnitude of magnetic field produced and not upon the direction. So let's say I am applying 5 Tesla of magnetic force in this direction or in this direction, the elongation will be the same. It only depends on the magnitude. So the basic idea, is it clear everyone?